So yesterday, yeah, I was showing the linear pattern and the circular pattern. Okay, and how to use the equation. So yesterday I was facing some problem here. So here, before using the equation, so what you have to do in circular pattern. So instead of equal spacing, so you need to select instant spacing. Okay, so you have to manually enter the angle between this pattern. So here we have 120 degree and we have three patterns. Okay, so click on OK, and now if I click on the circular pattern, okay, so here you can see the dimension over here. Okay, so the parameter one is the angle and another is the numbers of pattern. So what I'll do, this is called a column. So what I'll do, I'll drag it over here and place it over here. Okay, so now what I'll do, I'll use equation. Okay, so by I'll use equation to change the pattern. Okay, so what I'll do, I'll type here equation on the search bar and I'll click on the circular pattern. Okay, so now this dimension is visible. So first click on add equation, and in add equation, so what I'll do, I'll click on the degree. Okay, I'll click on the degree, and next over here, so I'll include the value or the equation. So 360 divided by, so I'll include this value. Okay, so divided by the numbers of pattern, numbers of item, pattern item. Okay, and I'll press OK over here. Okay, so now you can see the callout here. So now you can directly edit these numbers of pattern from here. Okay, so if I click over here, so now I'll change it to 2. Okay, now by using equation you can change the numbers of pattern by using this column. Okay, so there's option for this. Click on the callout, and let's say I want 4 patterns. I'll click over here 4 and press enter. Okay, so you can see the instant change in the pattern, numbers of pattern, by editing in the column. Okay, so for this you need to add equation. Okay, in this way you can add multiple equation over here. If I go to equation, okay, you can add multiple equation over here. Okay, okay, so next we'll move on to curve driven pattern and sketch driven pattern. Okay, so in curve driven, so we'll draw a curve and we'll try to copy the we'll try to copy the pattern and we'll place the multiple copy of this pattern in that curve. Okay, I'll search open. I created some pattern name shell. Okay, so I'll create a solid over here. I use bullet 10. Next, I use offset entities. Instead of offset, I just shell. I'll use shell afterward. I use extrude pause. I'll just drag this pointer, make it as 40. And okay, now I need to follow the part inside. So I'll use select this face and I'll take thickness of 3 mm. Okay. Next, so I need a pattern over here, cut pattern. For this, I'll select this face and Now I'll include a cut pattern over here. So I'll use a slow one. Okay. Next. Here I'll use cut extrude. Select the profile. Let me first cut the material. After cutting, so what I'll do, I'll select the sketch. Now I'll place the part. Okay, I'll place the part. So what I do, for curve, either you can use spline or you can use line. And 10. Okay. Next. So from here, I need to select the curve driven pattern. So in direction, I select this curve. And in features, I'll select the cut extrude. So open the tree and select cut extrude. Okay, so you can adjust the spacing and numbers of item over here. I'll take item of 12 and spacing of, sorry, okay, sorry. So it should be a single item. Okay, it should be a single rail. So I'm drawing this. I love it. Okay, I use a spline over here. Okay, so it should be single entity. There shouldn't be any join. Use curve driven pattern. Next, you need to select the part. Next, you need to select the cut extrude. Okay. So the curve method. Okay, so selecting this method, offset curve method. So they will place the pattern in a normal direction to this curve. Okay, they will try to put the pattern in normal direction to curve, or you can use transform curve. I'll use this offset curve. I'll reduce the numbers of items. That's the scale. I'll try to skip this part. Okay, so after completing, just press OK. I'll try to edit. So I'll start it from somewhere. Select the part, and over here I'll select the cut extrude. So change the numbers of pattern and the distance between them. Okay, so after completing, after doing this, just press OK. Okay, so in this way you can place the multiple copy of this cut on this curve. Here's another one which is called sketch driven pattern. Okay, so in sketch driven pattern, what you have to do, I'll use points to demonstrate this example. So I'll use sketch. Over here I'll place some point. Okay, so on this point, now I am to place this cut pattern. What I'll do, I'll go to features, then I'll select sketch driven pattern. Next, I need to select the reference sketch, which will be this, and the features to features and faces. So here I use the cut extrude. Okay. Okay, so in this way, you can place the numbers of cut extrude on the sketch. So, and the next one will be fill pattern. Okay, so for fill pattern, you need a boundary. Okay, you need a boundary. So for this, I'll create a boundary first of all. So yeah, I'll start the boundary from here. Somewhere from here, yeah. I'll use corner to corner rectangle. Okay, so within this boundary, I need to fill this pattern. Next, I'll use fill pattern. Then I'll select the sketch. Okay, here you have the pattern layout. How in what way you want to place the cut extrude. Next, you need to select the cut. So I'll select it from here, from the design tree. I'll reduce it by 5. Sorry. Yeah. Okay. So you can see here. So you need to select the cut extrude. Then you need to select the boundary. So inside the boundary, they will place the pattern. Okay, I'll just press OK. Okay, so this way you can create fill pattern. Okay, so fill pattern, you need a boundary to create this pattern. So I've completed the pattern. Next, okay, so we have some more features like hole wizard. Okay, so using hole wizard, we can create holes. Okay, so I'll demonstrate using demonstrative. So I'll create a account first. Okay, this is template. Okay, I'll extrude it up to some height. Okay, now to use the hole wizard. Okay, so you need to position the hole. Okay, hole location. Let's say I want to hold somewhere over here. So what I'll do, I will select the sketch. So either you can go by point method, or there's other option for this. So go to hole wizard, select hole. Okay, and go to position. So in 3D sketch, you need to place this somewhere over on the surface. Next, by using smart dimension, you need to add dimension. Okay, so I position the hole. Now I'll select the type of hole. What kind of hole do you want? So here we have different types of hole. We have counter bore, counter sink, okay, hole, then tapping, straight tap, tapper, Next, from here you can select the standard, on which standard you want to work. So I'll select ISO. I'll select the hex code, grade C, and the host specification. So here I'll use M8. Okay, so you can see the other parameter over here. You need to change it to see the effect on this model. Okay, now after completing this, just press OK. Okay, and we'll see the sectional view. Okay, this is how you can create hole. And if you want to create a simple hole, either you can use cut, extrude. You need to just create the circular profile and we'll use cut, extrude, or we have other option in hole wizard, just like contour sync hole. The option for this, just you need to select the diameter from it. Okay, here we have the standard diameter, or you can select custom sizing. Okay, so next we'll move on to advanced hole. So in advanced hole, you can create multi-step hole. Okay, so multi-step operation hole in a single go. So here you can see here in hole wizard. So here you can see you can do only two operations. One is the counter bore and one is the simple hole. Right. In multi-step, you can create multiple types of operation in a single go. Single pass. Now next, I'll select advanced hole. Same as hole. Okay, I'll select this space. Okay, I'll go to position. Okay, so I think there is no option to locate. Okay. So I'll place it somewhere over here. 30 and another from this edge at a distance of 50. Okay, next. So you can see here, this will be your near side from where your operation begins, and this will be your far side. So from here, I'll start with near side. From here, we'll start with counter bore, and I'll use the ISO standard. Over here, I'll use hex bolt, and the size I'll use M8. Okay, so after counter bore, I'll add another more. Okay, so I'll add another operation below this counter bore. So I'll just insert element below the active element, and from here I'll select the type. Okay, so here I'll select a hole. Okay, select hole whose diameter. So I'll take it as 4. It's small. Okay, so we can see the preview over here. Next, you can adjust the depth of the hole. Next, I'll try to add another more operation below it. Next, I'll use some tapping, straight tap below this. Yeah, stepping M5. Okay, so you can go by user defined value, or you can select the multiples of diameter over here. I'll go with if I'll go for 5. Okay, 4, 10. Okay, so after this, okay, so after completing this, press OK. Now, if I place this cross-section view or the cutting plane over here, so you can see here, so multiple operations are done in a single hole, right? So this is possible only in the advanced hole. Okay, so in simple hole wizard, so whatever are available, whatever types are available, you have to select one and you have to place here. Okay, so in advanced option, you can use multiple operation in a single hole. So here we have control hole. Next we have here is the hole, and here we have straight tab. Okay, so next, okay. So next we move on to under features. I have shown you how to use. Okay, so under fastening features, okay, so I need to show you an example. Okay, so under fastening features, you can add different fastening features like dip and group. Okay, to attach the male and female part of any component. Here, I'll try to move the body using this try. Okay, so here sorry. Okay, so here I'll show you the example how to create the lip and group on this part. So before that, you need to split the part. Okay, you need to split the part. Now I use the shell command over here. I select this space, I select this space. Use thickness of, let's say, 3 mm. So preview and then trace and out, and other hole over here. Okay, next. So I need to place the lip and group option over here. Okay, so that you can close this box. So go to insert, go to fastening features, and I'll use lip and group. So on this, you need to select the. Sorry, if you place the cursor over here, they will say show you what it is needed to be placed. Now select the body component on which you need to create a group. I'll select this body. Next, you need to select the. Okay, so select the body component. Okay, and next we need to select this. Okay, I select. Open group. Select one part and select the upper part. Next. So in group selection, I'll use this piece, and here I'll use the inner edge. Okay, I'll just remove it. I'll use that orange. And over here in the lip section, I'll select this face. I'll select the inner edge. Okay, I think I've created both same tab. Okay, so here over here I need to select the inner edge. Okay, so I'll remove these edges. Okay, yes, okay. So now you can see here, now lip and group has been, so over here we have group, and over here we have added some lip. Okay, so now I'll try to close this box. Okay, and we'll see the sectional view of this box. Okay, so this way you can create lip and group. Okay, so this is another fastening features available in SolidWorks. So another is the mounting pose, then bend, snap and hold. Okay, so I'll show you how to create a bend. So I need a vent over here. So what I'll do, I'll select a sketch and I'll try to create one vent. Okay, next I'll create a rib for the vent. Another rib over here. Okay, next I'll go to insert, fastening features, and I'll select vent. Okay, so in vent, you need to select the rib. So reset the rib, and you can adjust the thickness. Okay, next for spars, I'll add over here, and now to fill in boundary, I'll fill this boundary. Okay, so in this way you can add vent. Okay, so next we have here is mounting post. Okay, so this is another features available in the SolidWorks. So mainly used for making plastic component. Okay, so yeah, we have two type of boss. One is the pin boss and one is the another hardware boss. So in pin boss, we have male and female part. In hardware, you can use screw. So I'll select the hardware boss. I'll select this space and I'll place it somewhere over here. In case if you want to locate any specific location, so you need to go to sketch. Then you need to place a point over here and use dimension to locate specified location. We'll use mounting boss. I'll place it somewhere here. You can see here the parameters. You can change it over here. Okay, so okay, just press OK. Okay, so this way you can place mounting boss, and over here we have snap and hook. Snap and hook. Okay, so in snap and hook, okay, I'll try to show this example over here in this example only. Okay, so you can create either from the inside or from the outside. I try to create this from the outside. Select snap hook. Okay, here we have to select the face. So I'll place it somewhere over here. Next, the direction is okay. It is an upward direction, and to reverse it. Okay, so pass the snap hook. Select this face. Reverse the direction, and here it should be facing toward this face. Right, and face toward this face. Yeah, I'll make it face toward this face. I'll change this parameter E and make it as 1. What do I do with this? 1.5. Okay, so one feature is created over here. Okay, so let it. Okay, so I'll try to create from the beginning, snap and hook. Okay, so over here I'll select the position for location of the hook. This will be the position. Okay, next I'll reverse the direction. Please. This please. Yeah. And the height. Yeah, that's okay. Press OK. So this has been created now. What I'll do, I'll try to close this box. Okay, so now I'll use the cross-sectional view. Okay, over here I'll go to features, fastening features, snap hook groove. So here I'll use the snap body and the part body. Okay, so you can edit the parameters over here. So I use the default settings and press OK. Okay, so if I turn on the section view, so here you can see a group has been created for this snap. Okay, so what I'll do, again I'll try to move the body. Okay, I'll make it as transparent. Okay, there's an option for transparency over here. Okay, so not in here, sorry. In assembly, there's an option for transparency of the part. Okay, so you can see over here. So this is the snap, and this is the groove. Okay, so this is the last feature, fastening features. Okay. I think I've completed most of the topic from the part design. Okay, so next we'll start with the assembly module. Okay, so in assembly, we'll try to assemble the part which you have created in the part design. Okay, and we'll try to assemble using some relation between the parts. Okay, so first, what I'll do, I'll show you an example. So for this, I need to create a new document of assembly. Okay, so now I'll try to import the assembly. Okay. Into So I need to go to this location. Okay. I think some parts are missing. Okay, so I'll show you how to assemble a product. Okay, so first of all, go to Assembly tab. Here you can see the Insert Component option. Okay, so from here you can import the part which you have created in the part design. So I'll just go to Browse and I'll go to the location where I've created. Assembly. Yeah. Okay, so I'll try to assemble the part of this milling machine table. Okay, so starting with the knee. So I'll just click open and I'll place it somewhere over here. Okay, so now the position of the knee has been located. Now what I'll do, and the position has been fixed. So what I'll do, I'll try to remove the fixed constraint by clicking on float, and I'll use the move with right option. Okay, to adjust the position and limit. Okay, and after completing this, what I'll do, I'll try to fix the position once again. Next, I will import the okay, so I import the saddle. Okay, so I'll place it somewhere over here. Next, so now I need to place this saddle over here, right? And I need to add some relation between these two parts. So for this, to add relation, we have an option called mat in SolidWorks assembly. So what it does, it try to add relation between the surface or any body. So what I'll do, first of all, I will coincide these two face. I'll coincide these two face. Okay, so first I've coincided. Now press OK. So now what I want, now I need to place the saddle and place the surface near to the surface. What I'll do, again I'll select the surface and this surface. So SolidWorks automatically decide that we need to make these two surface. Okay, so there are option for this. You can either go manually or SolidWorks will decide for you. If there are two surfaces, so they will try to meet these two surfaces. Okay, so now they have added a relation called coincidence between these two surfaces. Okay, then press OK. So what you can do, you can check the movement now. Okay, so the saddle cannot move in this direction. That means the direction has been constrained in this direction. It can move only in this direction. So you can do this by clicking on any face and try to drag it. Next, I'll try to bring the table. Go to table. Okay. So here we have doctile join. So what I'll do, I'll try to meet this face and this face using coincident relation. Okay. And next, I will meet this face and this face. Okay. So we'll try to see the movement of this table. Yeah, it's working. Next. So here I need to place a bracket over here. For this, I use the bracket. I'll place it over here. Now, so what I'll coincide these two face. Okay, so if you're facing any problem, so what you can do, you can hide the table. Just click on any face, click on any face. So there is an option called hide component. Okay, next use mate, use the coincident relation, or SolidWorks will decide for you. Select both of these two faces, and SolidWorks will apply the coincident relation. Next, again these two faces. Okay, now try to move the component. Okay, so it's moving in this direction. What I'll do, I'll click on the saddle and make the right plane visible, and I'll click on the bracket. Okay, so the right plane is visible, so I'll click right plane of this bracket and the right plane of the saddle, right? So what I'll do, I'll try to coincide these two. Okay, so now if I try to move the saddle, okay, so the bracket will move along with the saddle. Next, I'll import a head. Okay, I'll place it over here. So the first relation, what I'll do, so you can see here there is a hole over here and another hole on this head. Okay, so what I'll do, I'll try to align the axis of these two holes. So use mid and just select the internal surface of the cylinder. Okay, so yeah, they will automatically align the axis. Next, another one, either you can use apply here, or what I'll do, I'll use the to move it right option, move in upward direction. Now I'll apply another relation between this space and this space. I'll use the coincident relation. This, okay. Now I'll try to move the component. Okay, so it's moving about this point. So I need to add another relation. Okay. So for this, so what I'll do, I use the parallel relation. Okay, so I want this face to be parallel with this face. So just select the faces. Okay, then SolidWorks will decide what kind of operation is needed or relation is needed. Okay, so now they've selected the parallel relation. Yes, okay. Okay, so next, turn on the table. And next, we'll insert the pillar. So in the pillar, you can see the orientation of the pillar. So I need to put this pillar into this hole. What I'll do, I'll try to rotate over here using this option. So I'll rotate about x-axis. Okay. Next, I'll place it over here. I'll use the mate relation again, and I need to align these two cylindrical axes. And another relation between these two faces. Hello? Hello?
Yes, sir.
I okay. Okay. So we need another pillar over here. So what I'll do, I won't import any component. Just I'll use I'll use the copy with mate option, copy with mate, and here I'll select this component. Okay, then I'll press the next button. Okay, next I will select the copy, select copy with mate, select this component, press next. Okay, so over here I have added two relation, right? One is the coincident and another is the okay, one is concentric relation and another is the coincident relation, right? So I need that part to be coincident with this surface, sorry, concentric with this surface and coincident with this surface. Okay. After pressing, press OK. Okay, so next again I'll import the other parts. I have the clamp over here. So in clamp, okay, I think the position is okay. And place it somewhere over here. I use the movie tried option. Okay, next use the relation. I'll use okay, so I'll use the concentric relation. Okay, next I need another part. Here we'll use the pin. Okay, so I need to orient the model now. I'll rotate about x axis. Yeah, and rotate about y axis. So I'll place it somewhere over here. Okay, now I need to import another one part is the rope. So use concentric relation between these two cylindrical surface and yeah, another concentric relation between these two surfaces. Next, again, another one between these two. Okay. Next, so I use the coincident relation between this cylindrical surface and this surface. Okay. So I need another part over here. The same parts over here on this side. Okay. So here, if I try to use the copy with mate option, okay. So here you see, if I select this part, if I select this part, if I go to next, so develops three type of relation. One is a concentric, okay, concentric between this shaft and this part, and another concentric between this part, and another coincident between these two face. Okay, so I cannot apply this concentric relation because I have not imported this part. So I won't go with this copy with me. I'll go with insert method. Go to clamp. Okay, I'll try to rotate the model by about x-axis. Yeah. Select the made. I'll make this as concentric. I'll use another component, which is the pin, and rotate about x-axis. Next, I'll rotate it about y-axis. Okay. I'll place it somewhere over here. Next, use the concentric relation So I'll make it transparent, change the transparency. Okay, so this option is available only in the assembly part. Now next use made, select this surface, select this surface, and this surface, yeah. And another relation between this surface and this surface. Okay, I'll turn off the transparency for now. Okay, next. Okay, in this way you can assemble the part. So now what I'll do, you can see the road extension, okay, from this space. What I'll do, I'll just calculate the length, how much it is extending from this space. So use measure and select on this face and press Control and select on this face. You can see the distance between these two faces is which is 11.5. And if I try to divide it by 2, okay, what I'll do, over here I've added some relation, right? Coincident relation between these two faces. So I'll try to search in the made option in the feature tree. Okay, so I'll just right click, edit over here, and here I'll use the distance option. Okay, so it was 11.5, right? 11.5 divided by 2. Okay. Okay, so now we have equal distance from this piece. Okay. Next. So next, you can see, I think the relation has been added. Now what I'll do, I'll try to limit this movement, okay, of the saddle as well as the table. Okay, to limit this, I'll use the made option. Made option. Okay, so this will be my last limit. Okay, initially we'll start from here, and we'll end it on this piece. Okay, so what I'll do, I'll try to see the length. Okay, what is the overall length of this knee, which is 500, and the length of the saddle, which is 304. Okay, 304.8. Yeah, 500 minus 304.8. So what I'll do, I'll go to mate. So I'll select these two fields, and here you can see, here we have advanced mate. In advanced mate, select the option called limit distance. Okay, so in the first here will be, this is the maximum value. Okay, I'll give here the minimum value 0, and in maximum value we'll add the 500 minus 304. Okay, and press OK. Try to rebuild it. Okay, so now it's done. Okay, so this is how you can limit the movement of the saddle by using distance option. Okay, so I'll see, now I'll see the distance of, okay, so do one thing. So first I'll limit here, place it somewhere over here. Okay, By using evaluate, I measure the distance from this face to this face, which is 533.04. Okay, 533. I'll use 533. Now I'll use the made option and I'll select this to face. Okay, and go to advanced made and select the distance option, and the minimum condition will be 0 and the maximum will be this distance, and press OK. Now I'll try to move. Yeah, it's okay. Okay, so in this way you can add the limit made. Okay, so in the made option there are other constraint relation. Okay, just like tangency, perpendicular, and in mechanical made we have gears. Okay, so I'll try to show the gear how to apply gears. Okay, so now I'll try to import gear from the toolbox. Okay, so if I click on the design library, go to toolbox and select the ISO folder. Inside this, I will use the power transmission gear. Now I'll include the straight bevel gear. Okay, wait for it. Next, use the module of, let's say, 1. Okay, numbers of date, I'll take 18. Pressure angle 14.5. So hot diameter, I'll take it as 10. Okay, this one. Face width 5. Yeah. Next space, okay. Okay, so I'll include another gear over here. Next, I'll try to rotate it using the right option. Okay. Okay, so what I'll do, so now I'll turn on the temporary axis from this option. So since I've imported from the design library, so they have created this design using sketches. So you can expect some axis on this part. So I can see here, this is the axis. And in the straight bevel gear, what I'll do, I'll turn on, I'll make it visible, the sketches. Yeah, the sketches are visible now. Next, so what I'll do, I'll try to merge it over somewhere. Okay, so next I'll use made option. So I'll click on this point and another point over here. Try to move one little gear. Select this one here. I'll import another one. Okay, so face width and try to keep it as 3. Okay, I'll rotate it. Okay, next I'll use the mate relation. I'll turn on the sketch for this cues. This and this. I want to be perpendicular. Okay, so I'll do one thing. And these two here. I'll try to import once more again. Okay, face width 3, half diameter 5. Model is 1. And remaining, okay. Another, I'll place it somewhere over here. And try to rotate using the triangle. Okay, next I'll use the mate relation. So this axis and this axis is perpendicular. Okay, next I'll bring this point and this point. Okay, so I'll try another method. Click on the assembly. So facing some problem over here. This point here. Okay, so first I'm going to take this weight and this is 3. Okay. Another component over here. So next, I'll turn on the sketch for both of these. Okay. Next, I'll try to place it somewhere over here. Next, I'll use a mate relation. So I'll make these two faces coincident. And by using try, I'll try to place it somewhere. Okay. Okay. So next, so edit it now. Just need to change the distance with that. Okay. Okay. Proper meshing cannot be attempted in SolidWorks, but you can search visually sorry. Yeah. So what I'll do, so this is the pitch circle, right? So what I'll do, I'll try to use the pitch circle. Okay. I'll use relation. I want to be tangent. Yeah. Clean selection. Okay, next what I'll do, I need to align the gear with the, with the right plane. Okay, so I'll just make it visible, and I'll take the plane number 3 of the spur gear and open over here. Yeah. So use mate, and from here I'll select the right plane and the plane number 3 of onboard. Next, I'll use distance between these two points. Set a distance this much. I think I've already set the tension, no need to set the distance. Okay, now I'll use the gear mate. Inside the mechanical mate, use gear and select the circular edge. or you can select a pitch circle. So you can give here the ratio. Okay, so how many feet? Okay, so there are 8 teeth, I think so. 2, 3, 4, 5, 6, 7, 10. 10 teeth. So 10 by 10 is okay. Now try to rotate. Okay, so now you can see the rotate component option, and if you try to rotate it, and the one thing, I'll create another part over here, create a new part, and select this space, and create a shaft over here. Exit case, and go to features, extrude boss, and edit component. Next, I'll fix this part. Okay, so where is the exclude? I'll try to make this with okay, so I have to create this part on another plane. Okay. I select this plane. I use this plane as a reference, and I'll place a distance of 2. Next, I use new part. I select this. Sketch. Do one thing, I'll create a shaft in part design here. Okay. So what I'll do, I'll create a part in any part design. I'll just check the diameter. I find it's 0.0. Okay. I'll create the shaft over here. 0.8 mm. Okay. Okay. Next, let's save it. Desktop. Okay. Next, I'll try to import it over here. And so, yeah. Okay, I'll add it from here only. Open the file. Okay. I'm gonna apply in dimension. So 0.8 times 5. 1.6. So next, use weight relation between two surface and another relation between two. Yeah. So I use okay. So next, okay. So next, I'll copy this part, concentrate with this surface, and make with this surface. Yeah. So I'll try to fix both part. Okay. So now relation has been added. You can just test it. Okay. So for this, use rotate component, and you can check the rotation. Okay. Okay. So in this way, you can use gear mate by going to advanced mechanical mate. So inside mate, you can select the gear mate, and in gear mate, you need to use the circular edges. Yes. So here I have given the ratio 10:10. Okay. So next, I think completed the assembly part. Now I'll move on to the surface module. So for surface module, I used some example to demonstrate the commands. Okay, so here I'll use the part module. So here you have surface module, just like the part design, we have over here extrude, revolve, swap, and lock. Rather than this, we have boundary surface, then we have fill surface, freeform, and the remaining are the modification tool. So what I do, I'll try to create a simple plastic bottle using the surface tool. So here, Okay, so by using surface module, you can create this type of product. Let's see another example. Okay, so you can create this joystick using this surface module. Okay, so I'll show you how to create this by using this command. Okay, so first of all, I take a new one. Okay, now here I need to sketch the profile first of all.
Sir, sir, do you have
Hmm.
means
Hello.
diagrams with all dimensions, sir? I mean, I want to make like something like engines and all. So, but I don't have any dimensions of them. So, where can I
Okay.
find it,
So,
sir? Sir, I have searched in Google also, but I didn't find any.
you won't be able to find all this command. I've used freeform and free curve. Okay, without any dimension. Okay, for the this assembly, this milling machine table, uh, I have the part file. So I'll send you.
Okay, sir.
Okay, I'll send you through Gmail.
Okay. Sir, like I made sir radial engine and all, but
Mm.
different other types of machines I can found in Google.
Okay.
Yes.
Okay. So let's start with surface. So first of all, I need to create the profile. Okay. So here, first of all, I'll use the center line. Okay, and I'll use the midpoint. Yeah. So what is happening now? Okay, I'll start with a new part design. Okay, so now I'll start with top line. First of all, I'll draw the center line. Next, other center line, horizontal center line. Okay, okay, it's millimeter. Okay, so now I use arc to draw the profile. Mm, I'll start one arc from here. And another arc from here. So I'm not using them. So, okay, now another arc I use from here. Okay. I'll add some color over here. Say 30. Next, remaining okay. Okay, so next, what I'll do, I'll use the sketch and I'll try to mirror it about this line. Yeah, so once it's completed, next, from this top plane, I'll create another plane. So either you can go to reference and select the plane using this as a reference plane, or I'll click on this top plane, I'll press the control and bring the pointer over here, and I'll drag it in upward direction and place it somewhere around here. Next, I use a sketch. I'll place the circle over here. Okay, the opening of the bottle. Okay, next I'll hide the plane and I'll use the front plane. Okay, so on this front plane, I'll try to draw the profile. Okay, how it will look from the front side. So I'll use spline. So it will look something like this. Okay, so now I can control this using this anchor point. Okay, next other, I need another spline over here, but in one sketch you need to draw only one spline. And what I'll do now, I'll use this point and this curve and I'll pierce it. Okay, next another over here, I'll use this point and the curve. I'll use the relation pierce. I can select the same plane and try to sketch another curve over here. Okay, so next, press Ctrl 8 and try to draw another guide curve. So I'll start it from here, go up to here, touch it somewhere over here. Next, the same way, I'll use this point in the curve and use pierce relation. Okay. Next, from the front view, the bottom will look something like this, and from the side view, I'll use the right plane. Select the right plane, press Ctrl 8. Okay. So in side view, so what I'll do, I'll use spline. Okay. Similar fashion, I have to pierce it. Okay. Exit the sketch and try once more on the right plane. So what I'll do, I'll convert this entity into sketch, and I'll draw a center line over here. Okay, I'll draw the center line over here. I'll use the mirror command, mirror entity, and mirror about this center line. Uh, Actually, I'm facing some trouble, so issue with the SolidWorks license. Pascal, license to কি আছে নো? Pascal, net to use কৰিছা নেকি? Net. Hello? Hello? Hello?
Yeah, yeah. Yes.
Okay, okay. So I'm having some trouble with the SolidWorks license. I am maybe due to the poor internet. Oh yeah. So we need a good internet for this to run the license of SolidWorks. Okay. So after uh, yeah. So what I have to do? Try to edit it. Okay. I set the sketch. Okay. So now it's been completed. Now what I'll do? I'll move on to surface. Next here, I'll use the boundary surface. So inside the boundary surface, I'll select two profile first. Okay. So from the front view, I want this material to follow on this curve. Okay. So for the direction, I'll select this direction. Okay. And from the side view, I want this surface to follow on this curve. So I'll select this direction and this direction. Press OK. Right. Next, press OK. Okay. So now it's done. Okay. So by using boundary surface, we can create this kind of surface. Next, I need to create the opening, bottle opening, so that I can place the thread over here. So what I'll do, I'll use the front plane, press Ctrl A, and sketch. What I'll do, I'll convert the entities. I'll convert these edges to line. Now over here, I'll use a line. License board slow. License. Net to slow. License slow. Net to slow. Again, license to come on. Yes, net to come by net use position. Set to put us. BSNL call class. BSNL call class. Okay. Okay. Now I need to draw the center line because this will be a revolve feature. So for this, I'll create a center line over here. Okay. and I'll set some distance from here to here, so something 18, and I'm using trim and trim this part. Next, I'll coincide with this line, so it is curved. I'll go to features and I'll go to surface and use the revolve. Select the surface. Okay. So now I have created the revolve surface. On the bottom, I need to fill this surface, fill this portion. So for this, I use the planar surface. Planar surface. So select the edges. Select all the edges. And press OK. Now, so what I'll do now, I need to join all the surfaces because I've created this surface using different commands, so I need to join it. For this, you can use the knit surface option. Okay, by using this, you can combine any adjacent surface. So click on knit surface. Click on knit surface and select whole body. Okay, and then press OK. Next, so what I have to do now, I am to convert this surface to solid. Okay, so there's option for that, which is called I think thicken. Thicken is the option to convert any surface to solid. Okay, so I'll click on thicken tool. Okay, so I'll use the thicken tool. I'll select the surface. Okay, so I'll use this thickness of let's say 1 mm or maximum 2 mm. Okay, I'll use the surface thickness of 2 mm and I'll press OK. Okay, so in this way you can add thickness to the surface. Now next, I need to add thread over here. Okay, so for this, what I'll do, we know that the arrangement is spiral, right? The thread arrangement is spiral. So what I'll do, I'll select a plane and use this as a reference. Reference. You wanna use 5, flip offset. This offset. Take it from here. I'll start the thread from here, from this plane. Now on this plane, what I'll do, I'll create a circle. I'll create a circle. So what I'll do, I'll use convert entities and I'll select the outer edge of the cylinder. Next, I'll move to features, and features I'll use a command called in curve. I'll use a command called helix and spiral. So using helix and spiral, you can input this helix. Next, here you can select define by what kind, in what way you want to define the helix. Your pitch is 5, revolution is 3. Okay, I'll keep it as 4, and yeah, that's it. Press OK. Now I want a plane which is normal to this point or this to the curve. So I'll go to plane. First of all, I'll select the curve, and the next I'll select the end point. So in this way, you can create a normal plane to the curve. Now on this curve, okay. Now on this curve, I'll just draw the profile of the thread. Okay. So next, I'll use the intersection curve. I'll click on the curve and press OK. Okay, so in this way, you can take out the edge. Okay, you can take out the boundaries. Okay, so where this plane intersect with the body. Next, I'll draw the profile of the thread. So I select the line, start from here, next here, and under over here. Okay, so I'll fix the dimension first. I'll use align dimension here, which is 3. Another dimension over here, and keep this as 1.5. So I'll set angle between these two. I'll try to keep it as 107. I'll remove this dimension. I use an angle of 107. Next, from here to here, yeah, it is done. Now I'll use the trim. Hello?
Excuse me, sir.
Hello? Yeah.
Sir, actually, sir, our director sir is waiting for this validatory function. If you finish within 5 minutes, then
Okay. Okay, I'll finish it.
Okay.
This is the last one. Okay.
Thank you.
So I'll remove this part. Okay, so now the thread profile is ready. I'll just exit it, and here I'll use the sweep and boss. I'll select the curve and the path. Okay, so now press OK. This way you can create the thread, and you can smooth the edge by going to sketch, select on the space. I'll hide the tool, and select the space and convert the entities. I'll use this space. I'll take out the edges, and yeah. Once again, I'll use the center line from here to here, and I'll use the revolve pose. So here I'll select this contours. Sorry, I'll use this as an axis and this as contours, and press OK. Okay, and another we need over here. Select the sketch and I'll click over here. Convert this space into a. Okay, I've taken this space and I've taken out the edges. Now I need to draw another center line over here. I'll use revolve feature in here. So I'll use revolve pose. This will be my axis and this will be my contours. Axis will be this. Yeah. Okay, before base, I'll select this as contours and this as the line. Okay, so maybe due to the sketch error. Okay, so this is not accurate. I have not done this drawing according to dimension. So what you can do, you can just fillet. Okay, I use the face fillet, variable size fillet. I select this space and this space. So I use this space, another face over here. And over here, I'll select whole line. This is not possible. Then I have to select this. Yeah. Okay. Okay. So this way you can create a model. Now to apply appearance, you can go to appearance on the right side of this menu. Here you'll find the appearance option, and from here you can select a type. So I'll select the plastic, and over here I'll select highly close and drag and drop over here. I'll select the faces, and over here, so I need to apply this appearance over here. So just select this, copy the appearance and place it over here. Select the face. Again, repeat for same. Okay, so in this way, you can create the surface model. Okay, so I will continue from here now. I think this is the last module and the last exercise, please. Okay, then, sir.
Okay, thank you so much, Navajit.
Okay, it's okay, sir. It's okay.
Yeah. Regarding the dimension, actually, this was a free sketch, right?
Yeah, it's a free sketch. According, if I go according to dimension, so the design will be much proper.
Yes. Okay. Yeah. Quickly, any queries from the students, from the participants? Any queries?
Okay, so I couldn't complete all the topics because there is this time constraint. If you want to know more about the software, okay, you can come to the TRTC Training Center, Guwahati. Okay, so we provide training courses on SolidWorks, CATIA, ANSYS. Okay, so either you can go to the come to Bamunim Center, or you can go to the Amigo Center. Okay, so in these two centers, we provide training courses on SolidWorks, CATIA, ANSYS, Unigraphics. Okay, and if you find some problem on using this command, so you can contact me on my Gmail address. Is there any queries?
I guess there are no more queries.
Okay. Actually, yesterday I didn't receive the participant list. So, is there anyone from your side who can coordinate this?
Vikas will.
Yeah. I'll send.
Okay
then, sir.
Okay.
So can I leave?
Thank you for wonderful session. So with this, we come to the end of the last session of this 5 days EDP program on design software for product development. Thank you, Dhruvajyoti.
Okay, it's okay, sir. Okay.
So, good afternoon, sir. We have Professor Pinakeshwar Mohanta, sir, Director, NIT Arunachal Pradesh, who have joined us. Sir, are you able to hear us? Mohanta, sir, are you able to hear us?
Yes, sir. I can hear you, sir.
Okay, sir. Thank you, sir. Yeah.
Okay.
Yes, Subhajit, you can start.
Yes. So coming to the valedictory session, I welcome all the participants to the valedictory session. We are pleased to have amongst us our director and principal investigator of the project, Professor Pinakeshwar Mohanta, sir, Director, NIT Arunachal Pradesh, and also our faculty colleagues who have joined us. So before starting on to the valedictory session, quickly we would like to hear from some of our participants regarding the feedback what are the things they have learned during this 5 days program. So any participants who would like to share his or her feedback? You can please unmute yourself and you can share the feedback quickly. Anyone?
I, 10 minutes I'll be here. I'm in presentation. You just
Kime, you are there? Yeah, any participants who is willing to share his or her feedback? Ankit?
Good morning, sir.
Yeah.
Good afternoon, sir. I'm Saurabh from second year. Sir, I would like to share my feedback that the session was really great. I learned the fundamentals about AutoCAD and SolidWorks was also discussed. And today in the morning session, the LabVIEW software was also discussed. It was a really nice experience. I got an overview for the software. And we are very thankful to you, sir, that you organize such programs for our welfare. And we are very grateful. Thank you, sir. It was a really nice session.
Thank you, Saurav. Any more participants willing to share his or her feedback?
Yes, sir. I Akhil Verma from mechanical department. Second year student. I am second year student, and I want to share my feedback on this program. I I can say that this type of program should be conducted from our college to enhance our skills, and it was really a wonderful session.
Thank you, Akhil. Anyone else? Anyone else quickly who would like to share his or her feedback?
Sir, good afternoon, sir. I am Kumar Avinav from Mechanical Branch, second year student. I want to give feedback. The workshop is amazing. I learned a lot of the things from this course. First of all, I learned AutoCAD and and its tool which helps us to design a lots of the things. I also learned the SolidWorks, which also helped me how to design and what it's help to in our futures. It's be really amazing. Thanks.
Yeah, thank you, Abhinav. Any more participants?
Good afternoon, sir. Sir, I am Bikash from third year in mechanical department. Sir, I am very grateful that uh, sir, I already learned SolidWorks and AutoCAD in my second year. Uh, Again, means by conducting this workshop, they again revised my everything, all the basics which I needed. Means I forgot a bit. So it was nice to uh, attend the workshop again. Thank you.
Thank you, Vikas. Okay, so now I'd like to request Director Sir, Professor Pinakesha Mohanta Sir, to kindly say a few words and address the participants. Sir, please.
Yeah. Dr. Mohanty and Dr. Subhajit Das, organizer of this particular workshop, resource persons from TRTC Guwahati, their participants, I'll first like to congratulate all the participants for successful completion of this particular workshop. The topic was actually very much important in product design, particularly whenever you go for entrepreneurship later on in your career. This type of SolidWorks, AutoCAD, or CATIA, these type of packages are essential for designing your product. Once design is done, then you can go for making the product templates and finally manufacturing of this product. Apart from that, you require to go for business modeling so that you can be a successful entrepreneur. Under the nectar, this type of activities has been conducted not only by mechanical engineering, by other department also. Our aim is to grow entrepreneurship, make you have some startups, and make you self-sufficient. Instead of searching for looking for a job, you go for entrepreneurship development. That is the better way of life. In that case, what happens? You become entrepreneur and you absorb some people under you. You can give job to others. That is the main motive behind this particular project. So I hope you got some idea. This might be very preliminary for 1 week or 5 days program, but most of you are from NIT Arunachal Pradesh. Some maybe from outside. We are going to have a particular laboratory, maybe virtual, maybe offline, with improvement, with different type of softwares, and attached to different type of machines like CNC, injection molding machines, so that later on all the people who want to be entrepreneur, they can use these machines and go for mass production and sell in the market. Like in India, mementos, small mementos are not common. Like places like suppose Khajuraho temple, a memento you can make. You can make a memento of the some of the national animals, national birds. These are not available in India, not much. Then there are some good here like Kamaksha temple or Tirupati temple. You can design it in your solid work, CATIA, etc. And finally, you can make a template and go for small mementos, which may be a keyring attached to it. It can go to market directly. So this type of things, even though look simple, requires lot of engineering practices. So we are there to help you. If someone come or a group come forward, we can always make you entrepreneur. We can help you. That is the main aim behind this particular project. So I hope in future there will be correspondence amongst the organizer and the students and the other participants, so that a growth in the line of Atmanirbharshil Bharat will be coming. With these few words, I'd like to conclude. Thank you very much.
Thank you, sir. Thank you for your kind words. Um, may I request Mohanty sir to kindly say a few words? Mohanty sir.
Yes, sir. Thank you, sir. So we congratulate all the participants. We also really happy that total 45 number of participants are taking part this week-long program. So we hope that participants have gained a lot of knowledge on design software like AutoCAD, SolidWorks, and other industry-based product and design software platforms. It also they can learn many things on conceptual sketching, 2D design, drafting, then 3D modeling and layout of the product. So the basic parts of this design software they have learned. So that they can when you go for the product design, they can visualize, analysis, and communicate with the design of different simulation parameters also for any component, so they can easily to modify also. So the participants are also very fortunate that they have got the exposure to the resource persons from TRTC Guwahati. I thank to all the participants for the lesson.
and they have got a lot of knowledge in the field of design softwares, and they're using the product development. Thank you, sir.
Okay, thank you, Mohanty sir. So let me propose the vote of thanks. We are very much thankful to Northeast Center for Technology Application and Reach, Nectar, for sponsoring us this project. And we are really thankful to the principal investigator, Professor Pinakesha Mohanta sir, for believing in us and giving us the opportunity to conduct this kind of entrepreneurship development program on design software for product development. Thank you once again, sir. And thank you all the participants. Hopefully, even though the 5 days might be a very short period for all of you to grasp all the knowledge for the two softwares that we have discussed, but eventually it will be the starting phase, and hopefully you will be able to take something from this EDP program. And I hope that you will definitely join us for such programs in near future. I'm also thankful to our trainers on CAD-CAM, especially Mr. Dhrubajyoti Teran and Mr. Mrinal Borthakur from TRTC Guwahati, who have really conducted wonderful sessions on AutoCAD and SolidWorks. And I'm also thankful to Mr. Priyaranjan Biswal, Assistant Professor from School of Mechanical Engineering, SOA University, Bhubaneswar, and Dr. Subhasri Kundu, Assistant Professor, Department of Electrical Engineering, KIT University, for enlightening us with the LabVIEW software in automation and other engineering applications, and also on design, modeling, and simulation of the product. So with this, we come to the end of the EDP program. Thank you all the participants. So the link for the feedback and the video lectures will be shared in the WhatsApp group. I request all the participants to kindly fill up the feedback form. And without the feedback, we won't be able to provide you with the certificates. So there will be few feedback links that will be available, made available in the WhatsApp group. I request all the participants to please fill up those feedback form as early as possible. Thank you. Thank you all. So with this, we come to the end of this program. Thank you for participating. Thank you.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.